and moderated by VK Anandan, Directors, ISTRAC, ISRO. Please, sir, can we have you on the stage, please? Our keynote address will be given by Mr. Harvinder Singh Nagi, Senior System Architect, Future Networks, Satellite Application Catapult, UK. I guess sir will be joining online with us, right? Okay. Our speaker would be Mr. Harvinder Singh Negi, Senior System Architect, Future Networks, Satellite Application Catapult, UK, followed by Mr. Niket Bhatt, co-founder and executive director, Digitron DefSpace Pvt Limited. Can we have you on stage, Mr. Niket? A warm welcome, please. Can we have a round of applause for the dignitaries? Mr. John Saripally, Managing Director, ComSat Systems. Mr. John, a warm welcome, sir. Mr. Riaz Lamak, President, Mahdi Bagh Computers Pvt Limited. A very welcome, sir. Mr. R.K. Singh, Managing Director, CPI Satcom Antennas. Antennas play a crucial role in the ground segment of satellite communication systems, as they are responsible for transmitting and receiving signals to and from satellites. With the rapid advancement of technology, several innovations are shaping the next generations of ground segment antennas. We will have a fruitful and interactive session, and I would give it to the chair and the moderator, please. Thank you, sir.
Very good afternoon to all. So far we are listening so much about the space and space vector, because so much of activity is happening there. Or expecting that industry is going to take over that in a bigger way compared to what ISRO was doing it. So from that angle, everything goes into space. Now I want to bring everybody back to ground segment, because ground segment, without ground segment, we can't imagine a space is going to work what we are talking about it. That's what the importance of the ground segment. So that is the most important part of element of successful mission or for a continued operation, because we can't just lift and leave the satellite into the orbit and leave it, because we have to be constantly monitoring it. So it needs a regular monitoring, control from ground for its intended operations, such as telemetry, tracking, commanding, and all sort of data downlinking, and for the purpose that what we have sent, all the sensor data has to come down. So it is a very important segment that, that also needs lot of change from the perspective of looking into its the way that we are going to explore the space, or India is venturing into such a level that how the space flaring nations, other nations are growing up. Much more than that, what that new space policy, which is last month, it has come out from the government of India. It talks about it. There are challenges. But what is the present segment of this, the ground segment? In particular, we talk about this antenna and all these things. We had a large number of building blocks for running the space segment, because we have come to know that, or when we initiated this opening up of the space market or the space segment to the private players, as well as the so many startup companies are coming up with a lot of enthusiasm and trying to pitch into because we are aiming for 2035, 2037, around say $2 trillion economy to bring it into the Indian continent only from the space. Now we are only talking about billion, but aiming for 10 to 15 years time, it should move to trillions. So once it expands to that level, we can imagine that what is the ground requirement or the ground reality we have to bring it up also, so that everything is happening with the intended or expected level of operations, and we are successful in the missions. From that context, these TTCs or the ground segment network is very important, and bringing it up to this level so that we are not missing the modernization is happening in the space sector. In parallel, the ground segment also need to explore. Present generations, because if I coming from ISRO, I can say that when we have 25 to 30 large antennas stations are there, which is constantly monitoring all which is specific to low Earth orbit and the geostationary orbits also, but that is a dedicated. But all satellites into a dedicated terminal as and when it passes through the top. So that is what the importance of ground segment which brings into the understanding. But a lot of autonomy is happening nowadays in the satellite segment also, which reduces the requirement of the ground segment constantly monitoring or looking into the satellite, what is happening there. But invariably, we have to have that control, because otherwise it will become a ghost tomorrow for our own system to collapse it. The reason is we are working on another segment that we are I am listening that morning sessions talking about satellite manufacturing industry. It is going to as a manufacturing division, like in a production line is creating it, aiming for thousands of satellites, and all are dumping it along with a lot of debris also, because the launch which brings to the top. So all are become a threat to the satellites. From that angle also, this complete ground segment needs a constant monitoring of the satellites. At the same time, we have to see that who and all around your satellite, so that the satellite is safe, or it needs a maneuvering, and you have to do the commanding to that point. Just like that, you call it as automation is created in the satellite, which reduces your control requirements from the ground. But the problem is created by us itself, because pushing out so much of satellites to the orbit, and part of it, so many second stage, third stage of the rocket's bodies also is flying around it. All this making more threat to the satellites. So the ground segment is the only one thing which can monitor and control and command it and look the satellites in a healthy conditions. So that also demands very high need of technology to be used or modernized, because a first instance so far what we do is every satellite there is a terminal which looks into the problems or dedicate when the pass is going on. But one terminal, one satellite, that strategy will not work out in the future. So there is a big change is required, especially the constellation of satellites which brings out, we're talking about 10,000 satellite constellations or 4,000, 5,000 by different company. For example, OneWeb, Starlink, and so many other people are also is jumping inside. In addition to creating threat to the working satellites, these are all functional satellites for the minimum purpose, and the intended operation is for the lifetime is very less. So we need to monitor this satellite also. Cannot just push it because its lifetime is 2 or 3 years. We need not too much worry about it. It does the job and leave the place. So, but that also to be monitored, maneuvered, because we are listening that one Starlink is around 25,000 maneuvering is done so far. So that is the need arises because of the other objects are in space. It's a threat to the other satellites, small, even though it is a small satellites. So that demands our ground segment again to modify it into a new system, which probably that a dish-based system is getting modified into a phased array, single phased array monitoring hundreds of satellites at a given instant of time in the hemisphere. So this is also need of the hour, which may come up very soon when we are aiming for such kind of satellite to put it into orbit for various purposes. So this is one thing. And we are also that, because any space flying nations, we can see that when they are always goes with an very exotic programs, leaving into outer space, into deep space. So that demands another kind of ground segment, which, because basically we talk about it, the EIRP, G/T and other technical terms. To satisfy that one, we need to have a big dishes, having a very good high gain and work on that one. But change is happening there, because again managing and maintaining this kind of infrastructure is again a big problem. So people are going in an innovative way. DSN array is building up. So that will do need basis configurations, so you can make it set up in the ground segment in a much better way. So these are the things happening in one side. At the same time, people are looking inside that one, how do we reduce the cost part of it? So that is what most important point of view. The economy is not there, the business model will not work out there. So how do we do the resources which is configured for that one, which can make use of it in a configurable way, like a cloud system. We talk about the clouds, and now everything is in the cloud. So here also, the common resources, put it in the cloud, put it through a high throughput links, and make it the viable solution that one processing will be done, need basis, wherever you can configure it, make it useful, and come back. So that will reduce, instead of dedicating completely for one ground segment with its own resources, complete chain is creating it. Part of it can be moved into cloud and secure the network, use it for the various, from geographically various locations, because you are in the master control area, you have to do this job. And you can put all the resources for the cloud systems. And the secure data point of view also, you can go into already established with a bigger way, that also can be in the cloud system. But again, there will be, and the secured network is a very important part of it. And at the same time, stored data should be secured. These are the challenges which will come inside. But probably there is challenges also that one, because if you are doing ranging, Doppler measurements and other things, we have to understand that one, how the cloud systems probably will work into that. So this is opening up a new area or new technology requirements in the ground segment also in a bigger way, when we are trying to see that one massive deployment of the satellites also into the outer space, or in the LEO orbit or MEO orbit or GEO orbit also. GEO is not that critical, because always it is constant in your outlook, or what we are looking at, it is okay. But this generates, or probably that one, what we wish to see here, that what are the opportunities exist, or what are the technology we have to look inside, and what from the distinguished speakers we may able to listen that one, what they are doing it in an innovative way, what best way we can approach it. So let me conclude here. But one point is, I was just looking that when a new technology area, which is not come up anywhere in the discussions, but quantum communication and the quantum computing, because that is already established, we are having control. Once upon we thought that one, it will be very difficult to make use of in our computing area, but now qubit controlling that one, and systems are developed, systems are now going to come in the market, all are happening. One more thing can think about it, but that was a philosophical, or it is in the initial stage of the particle physics when people are learning about the quantum entanglement. That's one of the area probably that can come in the 20 to 30 years of time, where devices to understand how to control that logic, the pair of electrons or something like that, it can have its relationship. When moment you decide something here in the ground segment and its pair is lying in the satellite, what you do, communicate here or change the state, and it automatically happens there. Lot of saving energy, and what we talk about in the ground segment now, probably that may not exist here. There won't be any big dish antenna, there won't be a question of G/T, there won't be any question of EARP and all these things. That may be a buzzword for tomorrow to talk about it, that once upon a time we are using it. If you are getting into that technology, my wish is like that. If you are getting into that technology sometimes in future, probably 20 years, 30 years, probably many of us may not be there also, it's not a problem. But that may be the ultimate for communications, and especially this kind of communication, what we are aiming to get it. So I stop it here. I leave to now the podium to the speakers, distinguished speakers here. So Mr. Harvinder Singh is come in line. Our keynote speaker is Mr. Harvinder Singh Nagi, senior system architect. Yeah, good afternoon. So now,
prepared a little video. Maybe it's worth playing that.
Okay.
Before we kickstart the conversation, and I very much align with what you just said. I was listening on this side. Yes, the topic is the beam forward and the phase very intense.
Okay.
So maybe it's probably worth playing that video, and then we can carry on the discussion.
Yeah. Stage is open to you, sir. You can start. Stage is open to you.
No, it's, I think it's with the CSI.
ऐसे काम नहीं कर रहा है.
Hi, my name is Joachim Espeland. I'm the CEO and co-founder of ComSat.
No. Sorry, it is no. That's the wrong one. Yeah.
My name is Harvinder Nagi, Harvinder Singh Nagi.
Harvinder sir. Sir, your file name, can you repeat? We'll just check it.
Yeah, of course. It's Space Congress 11.
Space Congress 11.
0723.
Sat Shri Akal, Namaskar, Salam, and good afternoon. Welcome to second edition of India Space Congress 2023 and discussion on next generation innovation in the ground segment. I'm delighted to be part of the discussion. Unfortunately, I couldn't attend the conference this year due to various reasons. My name is Harvinder Singh Nagi. Before we begin, it's important I introduce myself. I work as a senior systems architect within CTO team at satellite application Catapult. I have been in industry for over 28 years in different roles, mostly in managing development of defense, space, and ground-based hardware. In my recent role, I was head of engineering for a company designing payload for CubeSats for LEO constellation. My educational background is I have masters in engineering from University of Birmingham and masters in business administration from School of Management and Law, University of Bradford. So why are we discussing this? Currently, there are 4.5K satellites in LEO constellation as of April 2022, and it's predicted that there will be 58,000 satellites in LEO constellation by 2030. Now, these figures come from US government's Accountability Office. I have left the link on the slide, and also the name of the document where these figures come from. So what are the trends in antenna innovation for ground segments? Well, I've tried to narrow down to 5 points, but this topic is open for wider discussion. The first one is the higher frequency bands. There is increasing demand for SATCOM to be in higher frequency bands such as Ku, K, and Ka band. Q and V band between 37 to 75 gigahertz also been employed. Antenna technology is being developed to support higher frequencies, enabling higher data rate, wider bandwidth, and higher capacity for SATCOM. The second point is the ASA technologies. The traditional parabolic reflector antennas are still widely used, but there is growing interest in ASA technologies. These antennas provide flexibility in tracking multiple satellites simultaneously, forming multiple beams for different coverage areas, and adaptively adjusting their radiation patterns. These are gaining popularity due to their ability to electronically control the beam direction without moving the mechanical parts. This allows for faster beam switching, improved tracking accuracy, and reduced maintenance required for traditional mechanically steered antennas. These are mostly compact, flat structure, hence are becoming increasingly important for mobile satellite communications, for land, air, and sea applications. Their low-profile design, lightweight construction, and conformal installation make them suitable for mobile and portable applications. The third point is the phased array radar antennas. Satellite ground stations are also adopting phased array radar technologies for tracking and monitoring satellites. These antennas for radars provide agile beam steering, high-speed scanning, advanced signal processing capabilities, enables the improved surveillance, collision avoidance, and space awareness. The fourth one, which we already discussed in point 2, was the wideband and multiband antennas. So it's only fair if I just expand on it here. So there's a big push to accommodate the increasing number of satellite constellation, hence there's demand for such antennas. These antennas can operate across multiple frequency bands and communicate with multiple orbits and constellations. This also makes them stand out for flexible and efficient utilization of the available spectrum. The fifth point is mostly the algorithmic side of and the signal processing side of beamforming. So advanced signal processing and beamforming techniques are being employed to mitigate interference, improve signal quality, enhance capacity in satellite communications. This helps to dynamically adapt the radiation pattern to focus on wanted signal and blank off the interfering signal. Now, there are hostile signals also being employed to jam your communications. Hence the need for such technologies. The image on the screen shows an example of futuristic autonomous driver assisted system, or commonly known as ADAS car. And it can be seen that there's a need for compact, reliable, resilient antennas. This means there is a demand for reliable and hardware and antennas for sensors and communications. If I'm sitting in this car, I want to make sure the hardware antennas work efficiently so that I can have my journey with peace of mind. Wouldn't you? It is imperative that I should discuss 3 existing static antenna test facilities at satellite application Catapult UK, which are based in Harwell near Oxford. These facilities are namely the near-field range, the Qatar range, and the far-field range to cover all aspects of antenna testing. The final one is the dynamic antenna test facility, which is under development at the moment. This particular facility is known as CSAT. The acronym stands for Comms on the Move Electronically Stably Antenna Test Facility. It will incorporate SATCOM on the move vibration for land, air and sea, and will test reliability and integrity of signal under operational conditions. I would like to introduce 2 companies in the UK who are working on development of antennas and technologies, mostly customized ICs for beamformer designs. The company names are Celestia and Encelica. I will be showing their introductory slides. Both these companies are working as part of a consortium led by Satellite Application Catapult on European Space Agency program for development of Ka-band compact user terminal for high data rate applications. The first company is Celestia, which is a European group with Centre of Excellence in UK focused on next generation electronically steered antennas for SATCOM. Their group claims capability covering virtually all technology areas associated with space, particularly in the ground segment. The group strength is over 250 professional engineers and has turnover over 45 million with facilities in most European countries. Celestia's focus of work is to replace large array of individual mechanically steerable dish antennas with a single multi-beam solution. They are also developing unique phase array antennas, antenna gateways, to serve the emerging satellite mega constellations. A single Celestia eScan antenna can develop 20 or more Cassegrain antennas in a single compact unit, allowing it to be installed on the rooftop, city center locations, rather than in a remote area where the land is available for antenna farm. The eScan antenna discussed previously provides an instantaneous bandwidth of full 2.5 GHz in both TX and RX and addresses both left-hand and right-hand circular polarization simultaneously. The company also produced user terminal solution using its broad and deep expertise in electronically steered antennas. As you can see on the image, it's for automobile applications. The next company I'm going to introduce is Encelica, which is an IC designer company. The image below shows architecture of IC designed as part of ESA funded program. It also shows the technical details of the IC, which works for GEO and MEO constellation satellites. It has 4 receive and transmit paths and can support large array by daisy chaining it. It can support time division duplexing and a frequency division duplexing. This slide details the evaluation board of the IC, which was discussed in the previous slide, along with its graphical user interface. In summary, I would like to say these trends are real and are very likely to change the technologies of future, as reliability, resilience, and rugged hardware will be in demand. Without taking too much of your time, I would like to thank everyone for listening to me, and if the communication is established, I would be open for questions and further discussions. And if the terrestrial communication with the panel could not be established, then there is another reason to encourage SATCOM. I would also like to thank Anil Prakash and Rajiv Gambhir and rest of the SIA team for their huge effort for the conference. Thank you. Sat Shri Akal, Namaskar, Salam, and good afternoon. Welcome to second edition of India Space Congress 2023 and discussion on next generation innovation in the ground segment. I'm delighted to be part of the discussion.
But he can be in line. Thank you, Mr. Harvinder Singh. So we will go to the next speaker now, Mr. Niket Bhatt, co-founder of Executive Director of Digitron DefSpace Pvt Limited.
So thank you SIA-INDIA for giving me this opportunity to share my views about the next generation innovation in the ground system. So Dr. Anandan and Mr. Nagi point out very well about what future holds for the ground systems. So earlier we were having ground systems who were designed for particular applications. It has a single satellite operations, and as the number of satellites are increasing, we can also see the numbers from the video which Mr. Nagi has shared. So the next generation, as we move forward, so we have to think about breaking our ways from those stovepipe approach and go for the versatile, resilient, and interconnected systems. Now, as a startup founder, I have two perspectives. I may have one customer who is the government, maybe, and one customer who is on the commercial side. So from the government side, what government needs in the ground system is that the system should be secure, fast, resilient, this one. On the commercial side, what it should leverage large number of customer base. So it is not the same scenario where we need to control only the one satellite. We have very huge constellations up in the space, and that's how the new concept that to be able to reconfigure the ground segment also arises. So I'll give you an example that the similar kind of a thing which was discussed. If we are driving a car, we don't monitor the tire pressure by ourselves. We don't see that how speed is measuring. We don't measure ourselves. Our car system does that for us. So on the ground segment side, the similar thing which we are doing on the Digitron DefSpace is we are providing a complete platform in which the user will you can dump their code into our platform and they can use the ground segments as a service. So there is a new demand for making the ground systems for the servicing purpose is there with us. The additional kind of a thing is once we discuss about the new ground system innovation, we can't forget the already established old systems which are there in the operations. As Dr. Anandan said, we have a 15 to 20 antenna systems there already deployed, already there in the ground. So we have to think about how with this new reconfigurability concept, how we can renovate those things and adapt and use them again for our bigger constellations. So there is one more approach of having a more interconnected systems in our things. So there is one more things I'll talk about in the bullet points. One, the speed. Second, the resilience. Third, the versatility in a single system. So right now, if we like know about what Amazon is doing, they are building a same platform with the AWS to connect the whole infrastructure on a single platform. So that kind of innovation is needed on the ground segment also, and that's how we come into picture on the both side, on the satellite side, on the ground system side. So that's what actually I wanted to share. That on conclusion that in this field we need a collaborative approach to use ground systems as a service. As we have the ground systems budget cannot be more than 1/3 the whole satellite mission. So on the technical side and on the antenna side, there are now antenna systems who have a beamforming network which is controlled by the artificial intelligence and machine learning approach. This is what one of our product line will have, an antenna system, a reconfigurable beam, which is controlled by an AI-based software, which is integrated with the platform which I was discussing in this the discussion. So thank you so much for this, and looking forward to have the questions if there are any.
Thank you, Mr. Niket. Now I call upon Mr. John Saripally to.
Good afternoon to all of you. Good afternoon. So, Dr. V.K. Anandan and our co-panelists, Mr. Niket Bhatt, Mr. Riaz, Lamak, and Mr. Bhatt, and Ms. Singh, my colleague. Yes. We all heard about mostly now, the next gen, but let us go to the roots first, from where we have come. Today, I want you all to remember Dr. Vikram Sarabhai, who has started these space applications. He is the one who started these space activities. I don't know, the next gen may not be knowing. Since we know him, I just want to mention, because he is the one who has started this space. Department of Space has started with him. To start with this antenna technology, how we got it, it is he who first started that ESCUS under PRL, that is the physical laboratories and all that in Ahmedabad. And the first antenna was started in ESCUS in 1967 or 68. You can imagine. And later on, it is the Space Application Center, Ahmedabad, which has taken up the development of the antennas and all that. And incidentally, I joined in 1971 ISRO. That time, it is MASEC, Microwave Antenna Systems Engineer Group, but it is attached to Space Application Center, Ahmedabad. That is how I have started my, this innings. So I can say probably I may be a long surviving in this satellite communication. Almost 52 years I am in this line. Anyway, I am very proud to be in this line. I feel I am privileged because not many people can survive in this. It so happened when I was working, we were transferred to ECL, and that is how in ECL I have taken voluntary retirement. in 1991, having seen that there is a, opportunity for a private manufacturer of satellite communications, because at that time it was only ECIL, a public sector company, and of course Bharat Electronics is also there, but there was no private sector company. So that time there were no rules or anything. We were all treated as any, if not roadside, small-scale companies, it is all treated as you are one amongst them. Why I am telling, we have never got any support from the government or anything. Of course, I have to add, we had to go with the tenders and all that, and that is how we could stand on it. And not only that, if we don't supply on time, we had to incur LD. And just for your information, I am telling, almost 5 crores we have lost because, see, some timely, we could not give on time and all that, even though it is not a government's mistake. Now, why I am telling, some new entrepreneurs, they are thinking of coming and taking up maybe the present scenario may be different. But that time, as I told you, it was just you have to stand on your own, and nobody was supporting you and all that. Anyway, this is a generation, gone by. Just I want to tell you, there we have started. And with the real, support from ISRO, the ComSat systems could stand. And from 1991 onwards, we have manufactured many antenna systems, supplied to ISRO, supplied to defense, supplied to broadcast. And today I am very proud to say that wherever I go, I can see my antenna throughout India, even from Andaman, Nicobar, right up to this, Lakshadweep Islands or Kashmir or this one. Even today, we are going to supply some antennas which are going to be put in our Chinese border and all that. Now, just I am telling you, because this is how the company has grown. It is all because with the grit we have worked, and the support I got from my earlier, this one, ISRO, and of course, government I cannot say, because they have never done any, this one. Even the banks also, if your collateral securities are not sufficient, they don't give you anything. You have to stand on your own. This is how I have brought my company, or we could stand today for 32 years. And today our antennas are being, even exported to US, Germany, and other countries. Now, why I am telling, for the new entrepreneurs, so you have to stand on your own. You have to depend on your own technical capabilities and all that. But one thing, remember, don't leave it. Stick like a leech. Don't leave it. And definitely you will win. And that too, presently, with the SIA and so many organizations coming up, maybe the government may be giving some new this one. Not only that, I am expecting that even US and other companies may start now coming to India and all that. Now, coming to the subject part of it, see, when we started in 71, this site program was started that time, and it was S-band, and then all the, in uplink and all that, it is in C-band. Later on, we have gone to KU band, then to Ka band and all that. Now, we manufacture antennas right up to Ka band. But the next gen, as we are talking, I think next Q and V are also to be now thought of, because in the coming days, probably we have to graduate to that level. And another thing is now this with the advent of LEO satellites and MEO satellites and all that, now you require a different type of antennas. Of course, we have already manufactured these XY antennas and also train axis antennas to meet these requirements right now. But I think the much of is for these constellations and all that, beam scanning and all that, planar. I mean, just now we heard also with Harmeet Singh. I mean, he has given all those, I mean, future antennas. But I don't know whether any company in India has started manufacturing these beam scanning and this new set of antennas. But I think the future is mostly for these satellites, you know, you need to have the main, I mean, you need to have these phased array antennas with high throughput, QIV band supporting the next generation broad application. Of course, these geostationary satellites, these throughput antennas are being used now for the global internet access and satellite phones. It is already being done. And even we are also supplying some antennas to a other party. In the car band, we are giving something for this type of antennas. But the future, I know, the small antennas, I mean, these phased array with beam scanning and all that, I think that are to be manufactured. And I think some new company, today I heard about Mr. Bhatt, I think they are also working on that as I see. Good? So like that, a few, I think other companies also should take up, I mean, should come up and they take up the next generation, these antenna systems. So once again, thank you for giving me this patient hearing. Thank you all. Thanks, sir.
Thank you, sir. So now I'll invite Riaz Lamak.
Video is there on the desktop. I'll do it. Good afternoon, Dr. Anandan, my panelists, and the audience here. I'll be very brief. My background is, my company is into satellite communication ground services, but we don't sell any equipments. We are purely into services, which includes installation of small antennas of say 1 and sub 1 meter to a large antenna of 11 meter and 13 meter. We are coincidentally partners of CPI for their installations. And apart from that, we do a lot of work for capacity building and training. I have been wearing a hat as director for Global VSAT Forum, which has recently been merged with GSOA. So the work continues into training, into network audit and validation, teleport audit and validation, and humanitarian aid and disaster response. That has taken me across, and I'm always on the road, so about 100, 150 days in a year. I do speaking circuits and do projects. Some of the customer profiles would be mostly all the satellite operators, UN agencies, US DoD, and of course, Bell and ISRO and ECIL. That is where we started, and that is how we got the opportunity. We've done very large projects of rolling out about 3,500 terminals in 4.5 months to very large earth stations, right from civil foundation upwards. Why I gave this background is, since I travel, I have been in touch with many new startups and companies and new innovations. So today, for our interest, I've brought a very interesting concept of testing and validation of antennas from a company called ComSat. Now it's a startup about 6 years old and have matured. Their solution has been validated and have been tested. And now they are scaling up. So QuadSat is usually, like normally for an antenna validation, John sir and Dr. Anandan and Mr. R.K. Singh sir would always look at an antenna, then there's a bore site, and then do the testing and validation and fine tuning. But what these people have done is they have moved the bore site away, and it is there, but then they are using a drone to fly in a particular fashion, tied up with a complex software, and that validates the antenna, tests the antenna, then the application is used for any of the different groups. Say manufacturer would use it to fine tune and set the antenna to a particular parameters to its optimum use. An installation company or a government entity would check that it is properly installed. Defense would check from their perspective. So likewise, different perspectives are there. And just to sum up, this company has now got approval from 5 very large satellite operators, Intelsat, Eutelsat, SES, AsiaSat, and Inmarsat, that any antennas tested and validated by this company is allowed to work on their networks. So that's a huge, huge validation for the solution. And therefore now, ESA has given them a huge funding to scale up. Plus, they have also had another version of using a drone for testing the ground system, for calibrating the ground systems in a LEO environment, where they are mimicking the trajectory of the satellite with a drone and then testing it. So what I have brought today is a small video, very short video, and the founder and innovator who has made the solution, he'll talk to us about his solution.
Innovation in the ground segment.
Can you just
I'm
change this,
delighted.
please? This came up. Okay.
Hi, my name is Joachim Esplan. I'm the CEO and co-founder of QuadSat. At QuadSat, we use drone technology to empower seamless and secure access to the radio spectrum. Drone technology works at every stage of the antenna life cycle and helps improve access to performance data on location in a time-effective manner. This can be done through R&D, antenna qualification, production, site acceptance testing, troubleshooting, and ongoing maintenance. The QuadSat system is a drone paired off with a payload that transmits a test signal to the antenna on the test, where a ground control station collects that data using a spectrum analyzer or a power meter. A software then combines the data with the drone data to ensure that accurate antenna radiation patterns is generated. We use a RTK or a differential GPS to ensure that we have as accurate position on the drone as possible. Some of the results that are given can be seen here, where we have performed a raster scan. A raster scan creates a complete picture of the performance of an antenna. This has been very challenging to obtain in the field previously, and is mostly seen in laboratory measurements. This gives a detailed understanding of how the antenna performs. Another way is to simulate satellite trajectories, allowing you to test the tracking performance and analyze how well an antenna is tracking a satellite without using a satellite or satellite capacity. This can help check upcoming constellations or antennas that is intended to be installed in different locations. QuadSat has since has worked together with the European Space Agency and some of the major satellite operators in obtaining an approval to be able to measure and qualify new equipment coming to the market. And in October last year, Eutelsat, SES, Intelsat, AsiaSat, and Inmarsat all agreed that QuadSat technology can now be used to qualify new use terminals and larger antennas in the market that wants to connect on their network. QuadSat works with satellite operators to proactively mitigate interference, service providers to ensure that installation on site are done correctly and the components are working correctly, as well as antenna manufacturers in design, qualification, as well as new feature developments. We also work with governments and defense agencies to ensure their assets on the long term, as well as research institutions and academia to work on new and groundbreaking new methods, technologies. QuadSat was established in 2017 to be the world's first antenna test and monitoring solution on site. We have a team of 30 dedicated professionals working on this technology, headquartered here in Denmark, with offices in England and liaison and services in India. QuadSat is backed by some of the leading investors in the sector, such as Seraphim Capital and IQ Capital, as well as the Danish state. And we're trusted by some of the largest space organizations in the world, such as European Space Agency, Intellian, OneWeb, SES, Marlink, United Nations, and the Danish Defense. We have two engagement models. The first engagement model is a custom design where QuadSat team or our partners comes out and do the measurements. In this case, we will first examine the use case and the measurements and tests that are needed, and then at the end provide a comprehensive report that can be used to evaluate the performance of your antenna and actions on next steps. The other solution is that we actually provide a whole system. This is very beneficial for companies that owns a lot of antennas or tests a lot of antennas. Then the QuadSat will provide the training program as well as deliver the system over to the customer, and then the customer can do all the measurements themselves. Thank you very much for your time, and please let me know if you have any questions.
Since this is a new solution,
Hi,
I'll be more than happy to field some of the questions, but if it's more technical, I would definitely take it from you and either connect you with Mr. Joachim or get the answers for your questions. As far as commercials are concerned, with the both models, there are so many variants in the play, like what kind of testing, what size of antenna. So there's no one number fixed for a price tag kind of a thing. So on a case-to-case basis, number of antennas to be tested, size and the depth to be tested. Accordingly, they have a standard system which has been validated by all the satellite operators, and that's the commercial they'll be able to provide you. So thank you very much.
Thank you, sir. So now I will call upon Mr. R.K. Singh. Yeah, please.
I saw people overshooting. Presentation start. Let's move. Okay, got it. Thank you. So good afternoon, everyone. I know it's hard we wake up after lunch, but quite an interesting thing which is being told here. And thank you, Dr. Anandan, for giving this opportunity. As you all know that there are various discussion on ground station, and I'm happy to learn that yes, in a space technology, when people talk about satellite systems, people talk about baseband, RF electronics, especially some of the people, they thought that ground station is just the metal part and it's a physical thing which it's not a big physics in it, but it's not correct. Yes, we also play a very valid role. And the moment these satellite space segments are changing, it's a dynamic shift happening towards digitization of satellites, movement of satellites. Our antenna, our ground stations are also moving with a similar kind of development and technology. So I take you through the change in the shift of the technology which has happened for so many years. So these are some of the systems of VSAT mobile antennas, like, when you start watching some of the ATMs which has a fixed 1.2 meter antenna on top of the ATM, which just communicate 1 kbps or 2 kbps data with your banking systems. It started from there and then it went into a mobile antenna with DSNG, broadcast market, and then we moved on to different antennas which are for, these were all geo-related antennas where we were looking on a geo satellites. And then there was a shift towards LEO, MEO, and that makes us also to develop equipment in the SIM segment. So we also went up to a hybrid network. We are saying that it's like, let's try to develop some system which works for all the different layer of the orbits. So if you have something like, geo satellites, where we all know that, our major usage on DTH is based on the Ku band, geo satellites, and data and voice happening there. We still have the terrestrial backbone network where all used by satellite gateways. Then we have MEO, LEO, which is NTOC, and we have to develop some antennas which can rotate, track these satellites, moving of satellites, and give you connections. So there are markets, various markets for this ground station antenna. So this is one of the market where we have developed systems for telemetry tracking and command systems. So as Dr. Anandan very well said that, ground stations sometimes give control people, like, it's like a traffic happening in the space and you need an instructor down and you give the instructor a camera or a information data, at least what is going up in the air, and then, control it just to make sure that they don't crash each other's. Even if there are some debris which you need to remove, you use all these antenna systems. So these are movable antenna systems, mainly used for TT&C to health check the satellites, make sure the satellites roaming around is moving in the right orbits. These are some of the product which we have developed. Start from 1.8 meter till goes up to 6 and 7, 8 meters. These are LEO products where they can track, they can move very fast with the movement of the satellites, and they make sure that, you're tracking the satellites and you're connected all together. There are a few LEO tracking terminals in market, so we are one of them in all the bands. We talk about S-band, X-band, SX-band, and CPI does specialized antennas with 7.3 meters and stuff. There are some beyond line of sight, which is like, antenna which requires communication with UAVs and all those things. I'll come later. So we have similar antenna systems. There is a company called Orbital System, part of the CPI, where we manufacture a specialization in antennas market, which can cater to segments like weather or imagery or Earth sensor missions or a government or scientific sensors. So we operate on all the frequencies band, especially S and X, and K band, also an L band. You have been seeing that, of course, it's not good, but a lot of disasters management requirements are coming up, and you need to have, satellite will have a major role playing with our stations to gather all those scientific datas, imagery, and share with the people who can analyze it, and maybe artificial intelligence, AI, will be used to check what are the changes which is happening. So, of course, the ground stations antenna plays a very important role in that. We have antennas which we manufacture from, as I said, 2.4 till 18 meters, and we have deployed these antennas in India for lunar missions, which are being used by ISRO very well, and globally, worldwide, with ESA, NASA, and everybody. So there is another race happening for last few years, like who goes to the moon and Mars and all those places. So ground station plays a very vital role in this. sending people in a crew and bringing them back. And also all the data which are collected by onboard payloads and then bring it back down for studies. LEO, it's a big emerging market which all of us are seeing it. Thousands of satellites being launched in LEO segment. Maybe it's like for radar or for OneWeb, you talk about space links, and everybody wants to have maximum satellites. I understand that, the moment you have different satellites going into different orbits, you also tend to develop new antennas or ground stations, and that's what we have done. We have actually started using or developing towards the phased array user terminals, and this is how you can cater the market of LEO. So I'm not telling that, we will leave the market of GEO. The GEO market will still remain where the ground stations for other purpose, the fixed requirement or commercial will remain there. But yes, the commodity market, which is the LEO market, will have it separate. So it's like vast experience and vast applications coming up in the satellite ground stations. And that gives us a reason why we should keep on developing the ground stations for different reasons. These are some of the STS gateway antennas which we manufacture and installed for all the bands. And as you listen, a lot of other speakers prior to me talking about different band like K band, Q, V band. So these have been developed over a period of time and stabilized, and that's giving us more bandwidth and saving the energy and all those things. So yes, we have been able to reduce the total cost of solution by using these antennas in different frequencies. These are some of the pictures where you can have tri-band, like, you can have similar S, X, K tri-band antennas in the single antenna systems used for various reasons, receive only or transmit, receive, anything. And also for different launches of spacecraft for lunar missions and all those things. Currently, we are installing two of the antennas in India for similar mission for human spacecraft. They're 11.5 meter antenna with ISRO. The project is going on, and we're happy that we'll be part of that program when 2025 the spacecraft will be launched for India. These are all different sizes of antenna which has been installed globally. The first one you see is, I think, the India ISRO, the Bilalu site, which has been going to be used for the third moon mission. And these are full motion antennas which tracks and regulate the way you want launches and everything. Now this comes to the ground stations antennas, which are for various reasons, like used for LOS and SATCOM terminals, where you can see that we are part of the various programs where we manufacture antenna which can be used on copters, helicopters on the top of the rotators, UAVs, and ships and everything. So we are part of these all Grey Eagle, Anka, Global Hawk programs in US and other part of the cities. I'm sure that there are recently 2 weeks back when there was a discussion in US where General Atomic is supplying some of the Sky Guardians. We are part of that program of Sky Guardians, where our antennas and RF electronics are part of the Sky Guardian, which will be coming from G2G to India and will be used. So ground station, you have many such options and a variety of products. It's not only just the VSAT antenna, look up to the sky, but phased array antennas or mobile antennas or SATCOM on the move, marine antennas with gyro stabilized antennas, everything is there. This I talk about initially. This is basically for military use or tracking UAVs beyond line of sight, not the SATCOM antenna, but yes, it can communicate in S-band, C-band, and then it can track your UAVs and communicate. So these are some of the antennas. Of course, these are early warning, climate change, and natural disaster antennas, which are used from 0.6 meter to 2.4 meters. And these have been there in the market for many years. Only the things which has been changed is like it went from KU, CEX, KU, and then for the GEO satellites. And now when you talk about LEO and MEO, the model has changed from this dish antenna parabolic to mobile antenna or a phased array antenna or a beam steering, electronic beam steering, mechanical steam bearing, and beam forming, which people talk about here. And that's what has been changing. But yes, when we talk ground stations, it's not only the hub or a ground segment, but also the user terminal. So these are the user terminals which we are showing them. Thank you, and you're free to ask questions from me.
Thank you, R.K. Singh. Probably I'll ask few questions what I come to my mind from the presentations. Just thinking about the new gen requirements. Mr. Harvinder Singh, you are in line?
Yes, sir.
Yeah, I just want to know, because we talk about that all high frequency KA, KU band system. The new technology area, do you think that when the cryo systems also is part of it, the modification which requires in the LNA, which directly goes to the feed? Any attempt has been made in that area? When we consider that, because the cryo systems nowadays are highly miniaturized, the cooling systems are available which can be mounted, or miniaturization in the RF components or the subsystem level, the LRUs are happening across the industry. So what is your take on that one?
Yeah, I think there was a glitch in the communication. Just to get your question correctly, so you're referring to the
No.
semiconductors.
Yeah, I am just asking because you have a KU band, high bandwidth data transmissions or reception systems. So considering the advantage of the cryo systems, sub-zero temperatures, maintaining the LNA at the very near to the feed itself. Earlier it was quite difficult because of the various other reasons. Do you find any advantage if we can use it, or is a possibility now that it can go into the directly near to the feed itself and get an advantage of 1 or 2 dB in the overall G/T of the measurements?
Yeah, we have been actually working on one of my previous companies, a deep space mission for one of the ISRO-funded program for again KA band. So everything was mounted on the antenna itself. So all the semiconductors, we were exploring the possibilities of getting gallium nitride for high frequency. So yeah, with the high level of integration within the phased array and beamformers, it is possible, and you can maintain, you can adapt some heat sinking, mechanical system around it to maintain one single temperature, or at least to make sure that temperature doesn't change much. So yeah, I think it makes it easier with beamformers and phased arrays.
Okay, specific to beam, the phased array system, you are showing about the beamformers in the analog domain with proper phase shifters in the back end. Have you thought of it, or your company is doing the digital beamforming or post-beam steering method, which is the state of the art, which can be configured now? What are the difficulties you are facing, or it is already done?
Right. First of all, Catapult is not it's an organization. It's we are a neutral entity working government-backed funding, so we don't produce anything. So there are some projects we are thinking about the digital beamforming. Yes, we're doing a lot of analog beamforming, and one of the Silica's chip was actually designed with European Space Agency funding. But we're not currently doing any digital beamforming, but there are projects in the pipeline.
No, I am raising this the point of nowadays the SDRs, SOC, RF SOC chips are available in market, which brings the entire ground segment miniaturization in a great level, like we are talking about adaptability, reconfigurability, and other things, so that demand-based changes on the back-end hardware is possibility. So what do you want to say about it?
I mean, my personal point is these are being done already. The answer is that there's a lot of integration happening with the RF SOC Gen 3 we're working on at the moment, the program we mentioned about the CSAT, and the way the trends are, I would say it's going towards more integration, high level of high gain, high efficiencies, and multi-constellation.
Okay, thank you. Please be in line. I will put up to the audience if they want any specific questions come back to you. You please answer that one. Let me go to the next speaker, Mr. Niket Bhatt. You are raising about the configuration adaptability. What do you say about the frequency agility in the reconfiguration approach? Is it a possibility, or is the high bandwidth systems are being used? Bottom side. Bottom. Switches. Press. Oh, yeah.
Hello. Yeah. So when we talk about the reconfigurability for the frequency, there are two kinds of method possible. One is that we have a multi-band antenna systems in which that antenna switches its band. For example, it is working on some S-band or something. So it changes the band. It is a one approach. Second is within the band, in order to achieve, in order to like save the interference and between the consecutive bands, we switch the frequency within that band itself. So those are the two possibilities right now people are working on. One L3 Harris, we all know, they have up to some extent developed this reconfigurable whole transmit and receive systems, and they have deployed in the Iridium communication satellites so far.
Okay. Adding to this one, Mr. Riaz has put it that important point of the drone-based calibration. That is this is going to be the state of the art in the calibration, instead of we are talking about the tower or some other method earlier we are following it. But there is one more application which I am seeing there in the calibration along with the drone-based reconfigurable again antenna. So that is going to happen in the probably in the cognitive systems and other approaches when we talk about it. Are you thinking in that direction something to come up?
Actually, it is a one possibility, but right now it is very, reconfigurability is a very new concept. There are like layers. First is that the software-defined systems, then the adaptive systems, and the reconfigure is beyond those two concepts. So with this application which you have discussed, there might be possibility to have that, but right now I have no idea about any company working on the same.
Okay. So anyway, we have another speaker, Mr. John Saripally, octogenarian. We can say about its entire gamut of, because wherever you go in India, you can see wherever you are connecting to satellite, its antenna is there in the down the line. So that is the heritage he got it, and it is going to continue there. So I hope you are also going to shift it into new generation systems. And what we are talking about, we are aiming to that point. So that's only my comments on that one. Regarding RKSing, no need to say, CPI communications and all its delivered item across ISRO is a major user. When it comes to technology, immediately we want to do it for when you are looking for communications to happen to the deep space or wherever we are sending our satellites. So that point of view, they are very much integrated with the ISRO system very long back for their product and doing it. No matter that he is a veteran inside for that purpose. That is what we have to grow in that mode and see that one Make in India is one of the things which we are aiming to see that happens in a full-fledged mode rather than just talking about it. And so many things are happening. And seeing that one, okay, from Mr. R.K. Singh also, probably it's bringing system, probably there we may able to see that class 1 category modification as per the Government of India instructions that is going to happen. And service sector is the most important point, which is sometimes we'll say no words are neglected, but service and maintaining the system is most important point. And Mr. Riaz Lamak is doing a wonderful job and coming out with innovative approach in the calibration also with his systems, what he is talking about it. So that's what I want to say from my side. I open to the audience that any few questions you can ask it to any of the panelists.
See the.
Yeah, it's okay.
See the use.
Yeah, it is there.
See the user groups. If you look at, there are multiple. One is the antenna manufacturer, because when he's developing a product, he needs to test it to finalize the product, make a prototype and finalize it. So for that, he needs to do continuous testing. So he doesn't need to go to a test range or invest in a test range. So that is one area. Second is the satellite operators. Now they have humongous problem of interference happening on the satellites. And to reduce interference, there are various things. One is space data, another is quality of antennas, type approved antennas, and the quality of installation. So how do you validate the quality of installation? Just seeing two side lobes and a main lobe doesn't serve the purpose to the full extent. That's what we have been doing now. But if you really bring the antenna and install it to the OEM specifications, that it minimizes and mitigates interference. So that is another group. Then third is the satellite. So satellite operators would like to have a perfectly installed antenna. Then next is the service providers. Those who are doing installations, those who are providing services at large, they would like to have good antennas installed so that it is robust and it works well. So that's the third group who would be using these services. And last, and two more is, one is defense. Now, in the defense realm, I would not like to comment, but yes, it can be used for optimizing the antennas as well as other defense-related applications. So that is a fourth one. And the last is academia and research, who would like to better on a technology which has come. Or they are using antennas for some other testing and some other validation work. So they need a perfectly installed antennas. So for these 5 areas would be the primary users. Thank you.
Okay, I will stop here because we are reached to the time what is allotted to us, because even satellite misbehave, but ground segment cannot misbehave. So let me wind up with a dot. We are stopping it. Thank you, panelists and audience also, patiently listening to us. And I hope we have conveyed what we have in the ground segment and what is the future for us. Thank you.
Very thank you, the kind audience. Now, very 2 important announcements here. We will have a startup and investors meet at 3:50 here in the Regency Ballroom 3. All the startups are required to be present there. This session is powered by Invest India and SIA. After tea session, we have a combined session in the Oval Hall, the very first hall. The session will be hosted by Shri Prabhat Kumar, Special Secretary, and it's a very important session for the go-to-market strategies for space technologies. So we'd like you all to be there after the tea break at around 4:20. Thank you. Thank you, panelists, and thank you, Chair. Thank you, audience.
So, thank you.